Guys, our next speaker is Sujit Shetty. He's a director at Microsoft at Azure Data, and he'll be delivering the data management session. Some of you may have met him yesterday as well, right? So without further ado, take it away.
Thanks, Kabir. So I have a bunch of slides, and I think Kabir and we mentioned earlier that you'll get those slides. So I will not cover all of these slides, but I'll stop on some of the key elements of what we want to discuss, and please keep it interactive. I'll address questions as and when they come. Okay, so one of the key, and this is a slide that I actually cover across all of my, sessions, which is this whole idea of a digital feedback loop. And you will see this theme being repeated across a lot of Microsoft talks if you go to YouTube. The idea behind the digital feedback loop is while you're focused on your core application, right, the product that you're building or the service that you're building that goes to your customer, there is also an element of data being generated as part of those interactions, right? So you like, let's say for example, you're interacting with your customer as part of an app or a website. There's a lot of telemetry data that can actually get generated in those apps as well as websites, and that can actually come back to your systems. Similarly, the products itself, for example, can generate a lot of telemetry about how it's being used, and so on and so forth, right? So there is a lot of this information that actually is getting generated as you work, across your applications and products, and they in turn can have a huge role to play in terms of actually improving, enhancing both your product as well as your customer experience, right? So while you continue to think about what is the value that you're giving or product you're building or service you're building, also think of what is the digital feedback loop that you're building as part of your product and service itself, so that that insights can help you as you go, move forward in terms of building it out. Now, as we work with customers, there are 4 key themes that comes across from a data estate point of view, right? And when I'm talking about customers, I'm saying both enterprises as well as startups, right? The first one is more and more customers are building internet scale applications, right? Large scale applications that directly touch consumers or customers, have hundreds of thousands, if not millions of users and so on. And so the way you deal with that kind of data and application requirements is a little bit different from traditional line of business applications that enterprises have had in-house. The second element is analytics, right? Analytics is becoming very critical in terms of how you actually make sense of that data. And now with cloud, doing analytics in the cloud is much more easier and much more cost effective to do, and so that is the second trend that we see. The third one is modernization of your transactional data, right? And especially the last two are more relevant to enterprises rather than startup, which is how do I modernize data on the cloud as well as how do I modernize data on-prem, right? So I'll not cover the last one because that's not very relevant to startups, but I'll cover the first 3 scenarios in terms of how that happens. And feel free to stop me on any of these elements. Okay? So when we typically talk about internet scale data in the context of Azure, the one service that we most talk about is CosmosDB. CosmosDB is essentially, at the core, it is actually a document-based data store, which then supports a bunch of different types of APIs by which you can access that data, and different types of data structures as well: graph, document, wide column store, and so on and so forth, right? So let's, I'll talk about some of the core elements that DocumentDB brings in, and you could think of that along those lines. The first one is, DocumentDB, CosmosDB actually allows you to do global distribution with just a click of a button. So the way this works is, once you've set up your database on CosmosDB, if you want to now have the same content available, let's say in multiple regions. So let's say in India, you've set up your core databases, let's say in central India, and then you also want that to be available in South India because you have customers, let's say, that you want to distribute across, or let's say you want it in Southeast Asia or US or Europe. All you have to do is go to the CosmosDB console and just enable replication to these regions, and CosmosDB will take care of replication, synchronization and all of that stuff, right? So it reduces a lot of the overhead that customers deal with in managing multiple instances of the database, replication, synchronization, all of that stuff, right? So that is one of the key benefits that customers find from a Cosmos DB perspective. The second element is the ability to scale. So Cosmos DB actually provides you with the capability to be able to scale up and scale down and provision throughput again, with just a click of a button. So depending upon the size that you want to manage in terms of requests, you can actually scale up and scale down based on that. Right. The other element is latency. We actually are the only cloud provider which gives you an SLA on latency. So we actually commit less than 10 millisecond read response, and very often, our read responses are in the 2 to 4 millisecond range, right? But we actually give you an SLA backed commitment to say that every response that you do, every read query that you do, the response is actually less than 10 milliseconds. So that's the other benefit. Okay, and then another big thing is what is called as consistency model, right? So what we are used to from a consistency model perspective is either strong or eventual, right? Do most of you know what is consistency model? Okay, so I'll explain this a little bit. Consistency model basically means that if I have two copies of the data, so let's say I have my primary data and let's say another copy of the data, do I ensure that when I read data from, let's say, database 1 or replica 1 and replica 2, they will always give me the correct info, which is the latest info, right? With strong consistency, you ensure that there is no lag in the replication, right? So if data is written into database 1, database 2 will also give you the same result instantaneously. That is strong consistency. And eventual consistency means that at some point of time, database 2 or version 2 will also catch up with the copy 1 of the database, right? That's eventual. Now very often in your application scenario, you can't make a choice between strong and eventual because those are very limited in terms of option. Typically, you'll go with strong for things like transactional data, right? You'll go with eventual for something like catalog data. Because let's say, for example, think of an e-commerce site which has a catalog and it has a bunch of, let's say, product information for the SKU, right? If the SKU information is a little dated, for example, somebody updated, let's say, the dimensions of the product, and then let's say tomorrow they update it again, right? It is okay for there to be some amount of lag for that. But for transactional data, you don't want to be any lag, right? So if a product, for example, is bought, you want that product to be removed from your inventory system so that somebody else can buy that product, right? So depending on the data sources, you would pick either a strong or an eventual consistency. But what Cosmos DB does is actually allows you to have other types of consistency level, like how much of a lag in replication is okay, and so on and so forth, right? So depending upon your application data types, you can actually pick different types of consistency and then work on that as well. And then the other element of Cosmos DB is we support different types of APIs, right? So this is useful especially if you've already made a database choice, right? So for example, if you're already using, let's say, MongoDB, right, as your document database, right, then the benefit of this is that you can continue to write your applications based on the Mongo API and still be able to run it on Cosmos DB. You don't have to tie in into the Cosmos DB API, which is basically the core SQL API, right? And of course, there are a bunch of other formats also supported, like Cassandra and so on and so forth. Yeah.
So I have one question back on the back slide.
Yeah.
So let's say, on the Cosmos DB, so let's say in an application, so it does, it has 3 different modules.
Okay.
And so one module require strong consistency. Another one, let's say, based on the sessions, and the third one is the final eventual one.
Sure.
So can I have, so the DB is still the same, but can we configure in this Cosmos DB that each of these 3 can be made?
So short answer, no. So in Cosmos DB terminology, a database is called a collection. And essentially the decision whether to have strong consistency or eventual consistency should be based on the type of data, not so much the application that is accessing the data. So depending on the type of data, you should make the decision of whether it should be strong or eventual. And then once you've made that decision across modules, you can't change it.
So basically, what you are saying is then we need to have like 3 different Cosmos DBs.
You will have 3 different collections.
But can we have then a final one which can kind of aggregate the data from here, which can be like with delay, like it can have the eventual one?
Sure, you could do that, or you could do it at the application layer itself. So you could have an API in front of Cosmos DB to which all of your modules talk to and get the data from Cosmos DB. Yeah. Okay. So we spoke about multi-module and then we spoke about SLA. This is the other important thing. We actually give you a 5 nines SLA for read, and if you use something called as multi-master, Cosmos DB actually supports multi-master. We also give you 5 nines for write as well. 5 nines is one of the highest, SLAs in terms of availability that you'll get across any of the cloud providers, and that's one of the reasons why there are several customers who've used Cosmos DB as their core line of business database. What I want to do is now cover some of the use cases and some of the architectures that customers have used, and I'll talk about some of the capabilities in the context of that architecture itself, right? So the first one is a company called Jet.com, which got acquired by Walmart. The structure that they have, and this is for their core line of business application, is they have something called as Azure API apps, or Azure apps, that is used as their core application to which various systems talk to. And then they use Cosmos DB as a core database engine, right? In case of Jet.com, they use the core SQL API that is available as part of Cosmos DB. They don't use any of the other layers. The interesting thing that they've also done is Cosmos DB has a concept called as change feed. So anytime a new document is added or a document is modified or deleted, there is a change feed API that is available that gets invoked. So you come to know whenever a document is added or removed and things like that, and you can programmatically get access to it. So they use the change feed API to actually write, use an Azure function to connect to the change feed API and actually be able to push notifications. So some of the push notification elements that you need to actually somehow put into the database itself, where you'll have triggers and triggers generate, notifications and so on and so forth. A lot of that gets simplified in an architecture like this. The other interesting thing that they've done is use something called as Apache Spark, which is now also part of Cosmos DB. So you have created a core line of business application. You are putting all of these data into the line of business application. In a traditional analytics model, what you actually do is you move this data into another source through a process called as ETL, and then put it into another source to do analytics, right? So if you're running it on AWS, you would probably also have this data sitting on S3. You would call it a data lake and have some kind of a big data cluster that pulls data out of it, does some processing, gives you analytical report, right? In case of Cosmos DB, we made Spark as part of the Cosmos DB analytics, a Cosmos DB engine itself, which means you don't need to move data out of Cosmos DB, another data source, and do analytics. The Spark engine itself can talk to Cosmos DB and give you the analytics, right? So you can derive information through Spark, then push it to whatever dashboard, reporting tool, whatever is required to actually do reporting, right? So this is broadly the architecture that they followed. Okay, this is another e-commerce company called ASOS, and they are based in Europe or London, one of these places. They use Cosmos DB as part of their recommendation engine, right? So you'll see here, for example, all of the choices that you make, right? So you would have seen this in e-commerce sites where they say that based on your past purchases, these are additional items that you would like, right? So all of that information actually gets pushed into an offline data store, which is called Azure Data Lake. And then they have some kind of a big data engine, in this case Spark running on HD Insight, to actually process that data. And then this data is used for machine learning, right? So this, for example, so based on the data that they have collected, which means based on the user profile, what were the preferences that they made, and so on and so forth, you would actually put that into a data lake and have a machine learning model that actually learns based on that, and based on the profile updates what could be possible choices. So this is one path that gets followed. And then when you actually go to the site, there is a personalization service where all of these choices are written back into Cosmos DB, right? So you've done an offline based machine learning run across all of the user base, return that back to CosmosDB. And so once it's written back to CosmosDB, when you go to the site, you don't need to run the ML model on the fly. The results are actually pulled out of CosmosDB and provided to the user. Right? So this is another architecture in which CosmosDB could be used as almost like a caching layer, where the results of the recommendation engine goes back into a database, and then that database is used by the service to actually get the data. Okay. The other scenario is IoT. So for IoT scenarios also, CosmosDB has been a common data store. So Azure has a service called as IoT Hub, and we'll go into a little more detail around this in the real-time analytics side of things. But there is a service called as Azure IoT Hub, and that can actually be, basically Azure IoT Hub is where all of the events from your IoT devices actually go and land. And once they land there, you can use various big data services. In this case, they use something called as Apache Storm to pull that data out and push it into a database, right? The benefit of doing this on Cosmos DB from a information point of view is that Cosmos DB can scale up and scale down based on based on the capacity that you need. The challenge with IoT based projects always is that it is very difficult to predict when do events come and how often do you get events, right? More often than not, those events spike and taper off very often, and it's very difficult to resize your databases based on those requirements. So real-time kind of scenarios, IoT kind of scenarios, that benefit of Cosmos DB becomes very useful. Okay. This is a very similar scenario based on IoT. There again IoT Hub, but instead of using a big data service like Storm, they are using an Azure PaaS service called as Stream Analytics. But it's a very similar architecture that they also follow as well. Okay. This is a financial services. Okay, so this is a company called Clear Trend. They are in the business of actually giving financial trend reports. So this is basically an engine that investors can use. So let's say, for example, there are certain stocks that you want to follow, certain industries you want to follow. This is a product that investors or consumers can use to actually follow that trend. They collate information across multiple data sources and provide you with a common dashboard or a reporting service, right? And so again, the structure that they have is, Azure, various external services from which data gets pulled through Azure functions, and then that data of functions goes into Cosmos DB. And the reason they picked Cosmos DB is because document database does not have a fixed schema, right? As opposed to, let's say, a traditional SQL databases. So different external sources might have different formats, and so all of those formats could actually be stored within the same Cosmos DB collection, right? So the ability to have different schemas in the same collection becomes useful as one scenario. That's also one of the benefits of a NoSQL data structure. Okay, and then this is another financial services scenario, very similar, but the primary thing is that they have primarily gone into a very serverless kind of an architecture. So you'll see events are coming through Event Hub, ingestion of files happens through something called as Data Factory, and they use a bunch of functions and Cosmos DB. So predominantly, if you look at their architecture, it's all serverless. You do not have to worry, or the customer does not have to worry about how many nodes do I run or how much capacity do I have to keep as reserve. I can actually scale up and scale down based on the number of requests. Okay, so that is broadly, scenarios from a internet scale data, internet scale application kind of point of view. Any questions on any of the stuff that we covered so far? Okay, so let's move to the next segment, which is around analytics, right? And broadly, when you look at analytics tend to follow this multiple stages. Okay, so you have an ingestion phase. So you have various data sources, right? Today, for example, you might have LOB applications, CRMs, graph-based databases. At some point of time, you will bring in social data. You might have some kind of IoT data, telemetry data, so on and so forth, right? Depending on the type of data, like whether it's transactions, those kind of data versus events, right? You will use different technologies to actually do ingestion of that data. Once you've ingested that data, you need to store that data somewhere. Once you've stored the data, you will do some kind of analytics on top of it, right? So you may create some form of aggregates, give me the average sales for a region per day. All of those kind of data you will actually calculate and keep it ready. And then once you've created that analytics engine, you will have some kind of a serving layer so that users connect to that serving layer, get whatever data they want and so on, right? So this is broadly the analytic structure that customers follow in terms of the different steps and areas. Okay, so these are the services from an Azure point of view that you can leverage for each one of these stages, starting with something called as Data Factory. Data Factory is primarily used for ingesting data from various data sources, right? Then once you've ingested the data, you will store that data in something called as Azure Data Lake Store. Currently, we are in second generation of that. So when you actually, if you were to spin this up today, you will see something called as Azure Data Lake Store and Azure Data Lake Store Gen 2. Gen 2 is the one that you should pick if you're doing it today. Then from an analytics engine point of view itself, we recommend something called as Azure Databricks, and we'll talk about this a little bit. And then coming to the next stages. So let me move forward and we'll talk about it, right? So the core analytics engine that you would use to do transformation, calculations, aggregations, all of those things is something called as Azure Databricks on Azure. Databricks actually is a company which was created by the founders of Spark technology. And Spark is predominantly today the standard by which most companies are doing transformation, right? Spark is an open source project. So we partnered with the company that was created by the founders of Spark, and that they have created a first party service that runs on top of Azure, and that can be used for doing all sorts of analytics. There are a bunch of other benefits that it has, like we have deep integration into all of the different services. So we earlier saw things like IoT Hub, Event Hub. All of those services have deep integration into Databricks, right? So you do not have to worry about connectors and so on and so forth. Okay. The other element, so once you've done the analysis, you've created what is called as a data model or data mart, you push it into a data warehouse, and that is where something like Azure Data Warehouse comes into picture. Again, something like a data warehouse will be useful when you hit terabytes of data, right? So in the initial stages of your journey, you may not require a full-fledged data warehouse. You could just do with the standard database. But something like a SQL data warehouse would be useful once the analysis data becomes very high, it crosses terabytes of data, right? That point of time you would introduce something like this. But there are a bunch of other services that you could get. I've kept it there from a referenceability point of view. So whenever you get the slide decks, you have a good sense of what are the different services that fall into play. So let's look at the broad set of architectures that customers follow for analytics. Okay, so this is the most common architecture where you have a bunch of different types of structured or unstructured data. Azure Data Factory allows you to pull that data and then put it into a storage like ADLS Gen 2. Once you have put it into ADLS Gen 2, you can use Databricks to process that data and then push that data into data warehouse, and then you can have various reporting functions. Now, one of the common best practices that we recommend is do some form of auto scaling, right? So when you look at a database or a data warehouse, especially on the cloud, right, you need to be able to say that, okay, for example, take a data warehouse. Typically what happens in a data warehouse is you will do a lot of data ingestion into the data warehouse, let's say in the evening or the nights, and then there's a lot of reporting that happens in the morning, right, when your analysts come in. So when you're doing a lot of data ingestion, you want to scale up the data warehouse, but when the users are accessing, you don't require that level of capacity, you can scale down the data warehouse. So based on time, you can actually set up your Azure function so that it can auto scale the data warehouse and scale it down and so on and so forth, right? So those are some of the things that you could actually do as a best practice on top of it. Another interesting technology is something called as Polybase in the context of analytics, where if instead of calling data from your data warehouse, you want to call data directly from your raw storage, then that is also possible using something like Polybase, right? So you could use a mix of data sitting in data warehouse and raw data that is sitting actually on the store itself. Okay. An addition to this would be something like machine learning. So for example, if you have the same path that you could look at, but Spark itself also has a bunch of machine learning algorithms or platforms inbuilt, right? So you could take the same data that is coming. So think of, for example, telemetry data that is coming in, and based off telemetry data, you want to do some kind of personalization. So I want to take my users and then profile them and say, okay, this set of users fall under profile A, this set of users fall under profile B. Those kind of machine learning algorithms are built into Spark machine learning, Spark ML. And so you could reuse those machine learning algorithms to do those next level of profiling information. And then the third scenario is real-time data, right? So we saw this standard path for, structured batch data. But let's say if you have like sensor data, IoT data, social information like tweets and things like that, then you can use a different ingest technology. On, for example, Azure, you have multiple options. So you have something called as Apache Kafka on HD Insight. You also have Event Hub, for example, that you could also use, right? So depending upon whether you want to go with some kind of a serverless technology, so Event Hub, IoT hubs are serverless. In case of something like Kafka on HD Insight, you need to decide on the number of nodes and then be able to size it based on whatever your requirements are, right? And then that data can then go into your data warehouse as well, right? So these were the broad architectures that we see on the data warehouse, analytics, those kind of scenarios. Any questions on the analytics piece or the data warehouse piece? Any specific area? Go ahead.
Yeah. So how does Power BI comes in at the end after we have done the streaming
Right.
in, let's say, using Spark, then we put Power BI on top.
Correct. So Power BI is essentially just the visualization layer, and Power BI as a visualization layer can connect to a bunch of data sources. You can connect to a data warehouse, it can connect to Spark streaming directly, it can connect to Event Hub and so on and so forth. So depending upon what your business users want to be able to view and how real-time or batch-based data that you want to look at, you can then decide which data sources to connect to and get it. So that is the role that Power BI will play.
Power BI visualization, can those things be embedded into the existing application, or we have to kind of move the customer to Power BI specific?
So Power BI also has an embedded web kind of a interface as well. So as long as you can integrate some kind of a web frame or an iframe into your application, then you can use that as your so you can use Power BI in that way within your application.
So that's one way.
Yeah.
I'm talking about more on, let's say, some kind of widgets or something which can be used directly from Power BI and power our existing application rather than showing an iframe or anything.
Sure.
Because then it's kind of not the very good user experience.
Yeah. So Power BI is not designed to be widgets. Okay, so what you can do in that scenario is have those widgets directly talk to a data warehouse or something like a CosmosDB. So you have this data processed, stored in some kind of a data source, and then your widgets are able to connect to them either directly or through an API. That would be the architecture. You should not use Power BI for that. And then there are a bunch of these open source visualization widgets already available, so you can use any one of those. Any other questions on the analytics front?
Like Spark or you had shown in between.
Yeah.
And they also will have this visualization.
So Spark in the context of machine learning has a bunch of visualization built. So the way machine learning works on Spark is using a concept called as notebooks. Right? So what happens with that is you actually write the code there, and you could use some kind of a visualization library as part of your code to visualize data, right? So for example, if you're using Python, then there is visualization tools like pandas that you can use in your code, and the visualization will show up in the notebook itself, right? So think of Spark as primarily the compute engine, and then notebooks becomes one of the front ends by which you can visualize that data, analyze that data, write code around it and things like that. Yes.
So we could necessarily use notebook wherever we want in between and create
Exactly.
the PDFs and
Exactly. So if you look at this structure itself, right, Spark has its inbuilt notebook structure, so you can use that to access Spark, access the ADLS gen root, your data lake and so on. CosmosDB also has a notebooks interface, so you can actually use notebooks to access CosmosDB data, write code there, do visualization, all of that stuff as well. So there are a bunch of, and then there is also a standard notebooks tool available called Azure Notebooks, which you can connect to multiple data sources as well. Right? So depending upon what your developers feel comfortable with, they will work in that context.
So these notebooks allow, like Thompson was asking, to kind of export the data in different formats?
So
like PDF, Excel and all that, because our customer in the end needs either Excel or PDF output.
So that would be part of either the visualization widget or Power BI that you would use. Notebooks is primarily meant for developers to be able to work on the data and come out with some analysis. So if your customer has business analysts who can write code or who can write SQL queries, then to them you will give notebooks. But if they are BDM users who don't have coding experience, nothing else, they just want daily reports or functional reports, then those kind of things will go into something like Power BI, and then Power BI will have a way to export it as an image, PDF and all of that stuff.
Thank you.
Any other questions before we move on?
I just want to, traditionally we have been using ETL tools like Pentaho and all that.
Right.
And this is in concept your Azure Data Factory, we have to have a look at it, how it works. Kind
Right.
of thing. So if you can kind of explain the comparison between traditional ETL tools vis-a-vis this.
So I'll tell you. So if you look at the traditional ETL tool, which is something like an Informatica, Pentaho is the other one that you mentioned, they tend to work across Data Factory plus Spark, in the sense that the product are expected to do this Data Factory work as well as Databricks work. Okay, what has happened over a period of time is, especially the data transformation piece, right? So if you talk about ETL, it's extract, transform and load, or ELT, extract, load and transform. The transform piece has moved into open source technologies in a big way, right? So most companies have stopped using traditional technologies for doing transformation and are starting to favor technologies like Spark, open source Spark, to actually do transformation. So one of the things that has also happened is traditional ETL tools have now also embraced Spark. So if you write Spark code, you can also run it on top of a traditional ETL tool like a Informatica or a Pentaho, right? So that is from a transformation point of view. Now the other part is extract, right? Extract, in the general sense, you could still use a transformation in ETL tool like Informatica or Talent, or there are a bunch of such tools that are available, right? But if your primary intention is to just ingest data from different data sources and bring it to the cloud, then the recommended approach is use the tool provided by the cloud provider, because they are the best optimized for that cloud, right? So Azure Data Factory will have the best both performance as well as scalability on top of Azure compared to any other tool running on top of Azure. Similarly, the equivalent tool for AWS would have the best performance for extracting data out of your data sources and bringing into AWS, right? So the general recommendation is, whichever cloud you are using, use the PaaS service or service that they provide to extract data out and bring it into the cloud. Now, if there's some transformation required, then at that point of time, you take a decision whether you want to use a traditional transformational tool like Informatica, Talent and others, or do you want to rely on an open source tool like Spark, and then there are various ways in which you can run Spark within Azure and other cloud providers. So that's the general recommendation. Okay, so let's move from analytics. Okay, the interesting thing that Microsoft has now done, there's a very interesting announcement we made of a service called as Azure Synapse, right? And so this was the original slide, if you remember, which said these are the different phases. You have ingest, you have transform, and you have serve, and then you have the store layer. Synapse is actually a common platform that we have created which makes this whole process a lot simpler, right? So instead of thinking of different tools that you will do for different stages, you have one common workplace or one common studio by which you can do all of these stages, which is import data into Azure, make some transformations in the data itself, and then push it into a data model or a data mart. Okay, and the way we do that, there are a couple of ways. Let me just build out the slide first, right? So there are a couple of things that we do. The first one is, traditionally, the analytics platform used to have SQL. Now Spark is a built-in part of Azure Synapse, right? So what used to be the SQL data warehouse that you saw in that slide, we've actually expanded the capability of that data warehouse to also do transformation and bring Spark into the data warehouse itself. Okay, so your data lake store does not change. You continue to use the same data lake store, but you could use SQL or Spark. Both of these are then available to be able to talk to them. Once you do that, the other thing that we have added is this ability of doing on-demand, on-demand sizing of the data warehouse, which means earlier we used to support provisioned. So you would say that I require, let's say, a 4-node cluster that will talk to my data source, or in data warehouse you would use something called as DWs, which again translated to nodes only, right? With on-demand, what happens is based on the requirements that you have. So if it's a query which will require a lot of performance, right, it will automatically put up a larger cluster for you to be able to query that data and get you the results. If the query is a smaller query, it will automatically resize the cluster to a smaller size and then allow you to run the query against it, right? So the on-demand piece is the other piece that we brought into Synapse. And then we also built a standard analytics studio. So you do not have to worry about which tool do I use for ingesting data, which tool do I use for transformation, which tool do I use for modeling, and so on and so forth. All of that capability goes into the analytics studio itself, right? So this is currently in internal preview. This will actually release in 2020 sometime. But this is going to be a big change in the way you would do analytics in the context of Azure, because it simplifies a lot of these components that you earlier saw that is required to do analytics. Okay, let's move to the last section, which is data transformation or data modernization for your transactional data, right? So there are a bunch of different data sources or databases that are available on Azure. These are the ones that we already spoke about, CosmosDB and SQL Data Warehouse. But we also have a bunch of managed databases, starting from SQL database to MySQL, PostgreSQL, and MariaDB, right? So if you're already committed to a particular database, so let's say you're already using MySQL, already using Postgre or SQL Server, then you can actually migrate them as is onto Azure in a managed service format. Okay, what that essentially means is, this is what your responsibilities look like depending upon what you do, right, on the cloud. So for example, if you're running your databases on VMs, then it's your job to manage the operating system, the patching, the backups, all of that stuff, right? Moving to a PaaS service means that things like HA, DR, backup, things like database patching, provisioning, updating, scaling, all of that responsibility goes to the cloud provider. And your primary responsibility is around data and application. And that is the core benefit of running it, right? You do not want to spend time and resources and keeping the database updated, up and running. You do not want to create a database architecture yourself of, how many write nodes do I require, how many read nodes do I require, and so on and so forth, right? If all of that can be given out to a cloud provider, then that really simplifies life. So that's the whole idea behind having a managed database. So on the SQL side, we have a bunch of options. We have something called as managed instance. That is primarily meant for customers who are running SQL Server on-prem and want to move to the cloud. So if you're building a brand new application, you use something called as SQL databases on Azure. But if you're used to using an existing application and you want to move it to the cloud, then you use something called as managed instance, right? That's the primary differentiation. And then one of the interesting things that we have created on Azure is a version called as hyperscale. And the idea behind hyperscale is we've segregated out storage and compute, which means you can scale storage on its own and compute on its own without both of them being tied together, which is how the traditional model of databases have worked, right? And so if you read up about its architecture, there are a lot of interesting, innovations that we have done to come out with this. So similar to SQL, we also have for MySQL, PostgreSQL and MariaDB. So if you're using one of these databases, you could do that. And I've taken PostgreSQL as an example, but you could do something similar for others as well. Yeah.
So going back to the previous slide, like for the managed PostgreSQL.
Yeah.
Okay. So we have like currently one couple of PostgreSQL servers.
Okay.
So in master slave kind of
Yeah.
the mode. So when we say like when we say like managed PostgreSQL server in Azure case, and it auto scales up or down depending upon some metrics which we provide.
Yeah.
Like if the number of hits is beyond certain threshold for
Correct.
certain duration, you increase or decrease. How much is the latency during that time?
So
will the new request will stop for that duration, or how does that work?
good question. So there are two forms in which we provide you with scaling on top of Azure. We have something called as PostgreSQL single server, and we have PostgreSQL hyperscale. Since you mentioned PostgreSQL, you might be aware of a company called Citus Data, right? Citus Data actually was acquired by Microsoft, and Citus Data is available as PostgreSQL hyperscale, right? So depending upon whether you're doing single server or hyperscale, your method will change. In case of single server, you are basically just doing scale up or scale down, right? So in those cases, when you're doing scale up or scale down, there will be a few seconds latency when database will not be available when it's doing the scale operation. That point of time, your application, you'll have to code it in your application to retry after a few seconds and so on and so forth. Do a please wait in from a UI perspective and so on, right? So there is an expectation that you kind of plan this into your application code itself. But with something like hyperscale, which is Citus Data, it is a lot more seamless because you can keep adding nodes to Citus Data, and there is a coordinator node that sits in front which does all of these coordination across nodes, right? So if you go down the path of using something like a hyperscale Citus Data, then that whole thing of scaling up, scaling down is seamless to the application. It is done completely by the database.
Let's assume there is a single server itself, and if we want to go with the hyperscale case, how much is the cost difference generally, like for 20 GB PostgreSQL?
I'm not the cost guy, so I don't know that clearly, but the key thing is this, right? In case of single server, you're running just one node. The moment you go to hyperscale, you will need to run a minimum of 2 worker nodes and 1 coordinator node, right? So unless your data demands that you need to have multiple nodes, it may not make cost justification. But having said that, you will start on Citus Data with minimum of 3 nodes because you require at least 1 coordinator node and 2 worker nodes. That is what will happen. Okay. And the other thing to be aware is the way Citus Data is built is it is seamless from a migration perspective. It's built on PostgreSQL as a source code. So even if you start with PostgreSQL today, migrating to something like Citus Data is very straightforward. It does not take a lot of effort. Okay, so that is more from a database point of view. Okay, yeah, so that's broadly what I had to cover from my perspective. Are there any questions across Azure data or AI or any of the elements of Azure? Okay, great. So thanks for your time, and I'm sure Vinayak will share the slide decks with you. If you have any questions, you can reach out to him or to me. Yeah? All right. Thanks.